Hello and welcome. It is time once again to try to fix something, and today on the workbench I have a PS5 Digital that I believe is a no power. A little dirty, but no big scratches or marks all over it, so I do have it connected. Haven't taken the covers off yet to see if it's been opened or not. What does it do? It does absolutely nothing. Okay. Let's take the cover off and see if it's been, messed with before. All right, side plate is off, and I'm going to say quite possibly it has been messed with before. I'm seeing screws down in most of these holes, though, so yeah, I think somebody's been into it. That's never good. Well, obviously somebody has pulled the Wi-Fi antennas loose. The tape's torn. But the screws are still here. All the little silver screws, all 1,000 of them, are still in here. So I really can't see anything. Let me dig a little further. Alright, well, I have the power supply out of the chassis. Let's just see if we have a dead power supply. That would be nice. Nope, not a dead power supply. So we have a problem over here. Let's get it apart and get it inside. Well, we are inside the workbench, and we have the main board out of that PS5. This one is an EDM 10, so the original. Somebody had definitely been in here. Some of the screws were not quite tightened down, some of those silver ones. So somebody had been in here, but I really don't see where they had been working. I mean, I don't see any signs of flux yet. Let's do a really good job of cleaning it up. So let's just see what we can find as far as some shorts or opens, or hadn't had a blown fuse in a long time. Just never seems to happen that way. Continuity mode. 5-volt rail. No short on the 5-volt rail. Okay, what about around this? Yeah, I can't remember this part number, but it generates, of course, several. The 3.3, it generates several voltages. Takes in 5 volts. I'm trying to look and see where the outputs are. I think we're right here. It's like a 3.3 out, I think. No short there. No short there. Of course, that's ground pad. How about out here? I think that's ground right there. Yeah, that's ground. That's ground. So no obvious shorts there. Let's see. I think this is for the RAM over here. That looks fine. Anything over here shorted? I'm hitting some of these large coils that are, obviously DC-DC converters. Because there's no short on the 12-volt rail, right? No short on the 12-volt rail. How about around the HDMI encoder IC? Make sure I'm getting a good ground connection there. Nothing reading shorted there. Okay. Not here. Nothing there. It's another DC-DC converter. These are for switching out to the HDMI port. Switching the 5 volts out. That's gonna be, these are low impedance lines here. I think that's pretty normal. pretty normal. I think this is a 2-volt generator related to the SSD circuit. Nothing there. That's ground. How about across? This is fuse F7003. It's good. F7502. Good. That's a 5-volt fuse. F7001. Good. I don't think there's going to be any of these because I should probably go ahead and fire up my bench power supply. Should probably take a look and see what kind of current it's drawing. That tends to tell you a lot. Should fuse here. No, it's not a problem. How about any shorts around this SSD, the generator for the SSD controller, like a 2.5, 1.2, 0.8, that kind of voltage. I think that's ground there, yeah. Nothing obvious. Just checking on these capacitors right there, electrolytic capacitors. Nothing. How about around our south bridge? South bridge, of course, is on the opposite side of the board right there. Anything? Oh, yes. Yes, sir. 3.5 ohms. That's on a line going into the south bridge. I wonder where that supply is coming from. I can't remember that. I think that's like a 1.8. I can't remember. But it's dead shorted. Well, not dead. I shouldn't say dead shorted. 3.5 ohms. It's dead enough though. So I believe those rails should be coming from, yeah, this IC right here, which we checked earlier. But I did not hit every pin. See if we can find that 3.5 ohms short on one of these pins. May have to get under the microscope because I can't see all these little pins. That's not it. I mean, there are some of these rails that are coming out and going to that south bridge. There's no easy test points right here. They just kind of come out and go through a via into the board and disappear. 3.5. Oh, you can see it right there. There's that same 3.5 ohm short on these two inductors still going into the south bridge, and coming through a via right there. I don't think that comes all the way over here. No, it's got to be here. Let me see if this is an RT5126 or DA9065. How do I turn this where it's turned the right way? Just some notes I had. Okay, pin 1 is up in this corner, the upper left. So it'd be kind of like that. I don't know if that's going to help me. Looks like there's a 1.1 on this corner right over here. I'm just running that probe down through there. That's ground? Yeah, that's ground on that very corner. What about on this side? I'm just too lazy to switch to the microscope view right now. Oh, there we go. 3 ohms. There it is. I see a tiny capacitor. I see some vias it goes through. That's it. So it is still very hard to see. That's it. So it looks like it's the second pin in. All right, let me look under the microscope just to try to confirm. But it looks like it's going to be a switched 3.3 volt output. Switched by this, well, I'm not sure what controls it. I'm guessing, I don't know. You would think Southbridge? Because some of these outputs they're just, well, that may be a constant output. There are some of them that are constant 3.3, and there are some, that are switched. Like, looks like number 16, according to my notes here, has 3.3 on it all the time. 15 has it on there momentarily when you apply power, and then it goes back away. And it's probably, so my notes were taken during the boot or initialization process. Let's see if we can switch to the microscope cam and get a better view. All right, finally broke down and got the microscope out. Wake up, multimeter. So I have not changed the board orientation, so I have it turned the same way. So our short is right here on this capacitor, 3.5 ohms. And according to my notes, yeah, that is a 3.3 volt line that is switched. Somehow something controls this. Probably the Southbridge tells us to enable that output or not. Not totally sure what controls it, but so I'm rather sure that this chip is fine. They're pretty good. They don't break down a lot unless you have lightning. Dialog DA9065. Some of them have a DA9065. Some of them have an RT5126. As far as I can tell, they both work the same. So our short's going to be in our Southbridge, because the Southbridge has a piece of wire I should probably get rid of. I wonder where that came from. Off of my workbench, and I just dropped it. Okay, who knows what that's going to short out. It went flying out of my tweezers. Here's a couple of rails that get that voltage going into the Southbridge. Yep, 3.5 ohms. Anyway, I'm pretty sure we just need a Southbridge. Easy peasy. Let me get this in a board heater, and because I like to use a board heater, if for nothing else, for putting the Southbridge back on, just so I can use less heat from above. You don't have to, but yeah, I like to. It just makes me feel better to do it anyway. So which one is this? This should be a 61GG. I think I've got some of those on hand. Let's get that swapped out, and I bet you that solves our problem, our no power issue. Well, our south bridge has been changed, and I think I've even cleaned up underneath the south bridge to get rid of the alcohol and the flux, so maybe that won't be a problem. I think I'm going to do a quick check of the current draw before we take it out to the garage. I should have done that before, and I would have maybe figured something out quicker, but polarity is correct. Let's just see how much current we draw from 12-volt supply here. Yeah, that looks pretty close to right. I'll come back down. Why are we hanging? Why are we hanging at 290? That does not look normal. Nope. We're stuck at 290 milliamps. Okay. But we finally dropped back down. Let's try that again. That's power's off. Now power on. Go up to close to 300 milliamps. Sure is hanging a long time. Don't like to see that. Hanging a long time. Yeah, that doesn't look good to me. Well, I think I may have spotted the problem. Let's take a close look under the microscope around the south bridge, just to the left of the south bridge, the way we're oriented right now. And yeah, that could be the problem right there. I think that should be over here somewhere. And my tweezers have gotten awful fuzzy. Get that cleaned off here. Yep. That could be why we're hanging. Let me get my hot air station worked up here. Hooked up. Lucky I didn't lose that little coil. See if we can maybe tin this a little with some leaded solder. Now, can we relocate that coil without losing it? It looks like it's barely hanging on there. The ends are bothering me a little. I need to clean that up. I don't know why. There, these are shiny now. All right. Here's some fuzz. Let's try this out again. Should be much better this time. Well, our inductor is back in place now. Right in there, if I can get it to focus. So maybe now that the south bridge has all of its power rails, focus. Let's see, yeah, I'm still connected. Let's see what kind of current draw we get now. 300, Nope. Now our oscillator's not running. Anytime I see one sit at 9 milliamps like that. Oh, there it goes. It dried out and worked. 300 milliamps. I'll come back down quickly. Why are you doing this to me? Why do you hate me, PS5? Turn it off. Oh, now we're just acting stupid. Okay. That looks like that oscillator is not running. The 32 kilohertz oscillator. Because I probably have flux and or alcohol up under the edge of the south bridge. The crystal's on the other side, but it connects to, you know, pins right up under right up in this area. I suppose it is. Let's see. Where is that oscillator? Why will you not focus? Where is that? There's that oscillator. Right there. Alright, so I'm going to apply a little heat. Just for the heck of it. In case there's some flux under there. Just a little. I'm going to try to run some alcohol underneath it. I'm going to take some canned air. That should be pretty clean. Alright, I've cleaned out from under the south bridge. Cleaned it and dried out from under it with some compressed air. Still connected. Now what do? Up to 300 milliamps. Come back down quickly. There we go. That's much better. That looked like a normal initialization. Alright, now maybe it'll work. Okay. I think we're ready to take this back out to the garage and see if we have a working finished product. We are back out in the garage. I've got this PS5 put together enough to test. I did have to clean up the liquid metal a bit. It had some dark spots on the heatsink and on the APU. Got that kind of cleaned up, polished up. Just moved some liquid metal around. It looked pretty good. I think we're ready to test. Do we do anything now? Yes, we do. Oh, saw the monitor lock. Come on. I'm sure it wants to do a storage check. Okay, monitor locked again. There we are. So another dead south bridge. I have not had a dead south bridge in a while. In quite a while actually. But I think this is going to come back to life. Of course, that's not really a cheap fix. Those south bridges are like $40 each or something now. 61 GGs. But it kind of had to be done, or this is a big paperweight. Alright. I think I will just end this one right here. I think she's going to be fine. I hope you thought that one was kind of interesting, educational, or something. If you did, please give me a thumbs up. And I will see you in the very next repair. So long for now.